Blah, blah, bro, help me. Fourier series are just a bunch of calculus symbols crawling around like worms? I feel like my brain cells are committing mass suicide right now.
Oh, Fourier series. What if I told you that with just one phrase, you could see through all its calculus fog? Principle behind this phrase is from the same lineage as the creation method of AI. Do you want to learn it?
AI? You're fooling me again. Fine, teach me quickly. What is the phrase?
This is the founding principle of the Guild of Perception. Inner product reveals all.
Are you kidding me? I've never heard it. What does this have to do with Fourier series?
Don't rush. Let's start with an old friend we've known since high school, the vector inner product. Do you still remember the geometric meaning of the inner product?
Of course. A dot B equals the magnitude of A times the magnitude of B times cosine theta. I'm a science student, you know?
Now look, what happens to the value of their inner product as we continuously change the angle theta between these two vectors?
Is it true that the closer the directions of A and B are, the larger their inner product value? If the directions are opposite, the inner product value becomes the negative maximum.
Precisely. The inner product is the universal language the universe uses to measure how similar two things are. Algebraically, it's a series of products accumulated. Depending on the vector form, sometimes we use matrix multiplication, sometimes we use the summation symbol, and in the world of Fourier, we use integration. Now imagine if we treat a periodic function, f of t, and various sine waves, sine, cos, of different frequencies as vectors living in an infinite dimensional space.
Wow, that's a cool analogy.
Then, by performing the inner product between this periodic function and the sine waves, vectors of different frequencies, wouldn't we be able to see the degree of resonance between this periodic function and the sine waves of various frequencies? The opening move for inner product reveals all is similarity is directly proportional to the periodic integral from 0 to t of f of t multiplied by cosine of n omega t, then integrated with respect to time dt.
Stop. Don't trick me. This doesn't look like the formula in my textbook at all.
Don't worry, this is just the first step. A simple inner product can only reveal the trend of similarity, but it cannot directly compare numerical values.
What does that mean?
It means we can only tell whether there's a mouse dropping in a pot of congee, but we can't distinguish between a single rice in a pot of mouse droppings or a mouse dropping in a pot of congee. In both situations, the mouse dropping detector will alert, but the concentration is worlds apart.
Then all that calculation is still not very useful.
Therefore, we must standardize our comparison tool. It's very simple. We make the similarity of a sine wave with itself equal to 100%. This gives us a fair baseline for comparison. With the blessing of this standardization factor, the power of inner product reveals all is even greater. We can let components of different frequencies compete fairly in the same arena and directly compare their quantities. The second form of inner product reveals all is that an equals a fraction, where the numerator is the periodic integral of f of t multiplied by cosine of n omega t, and the denominator is a periodic integral of cosine squared of n omega t.
The formula in the textbook is very complicated. How is yours so simple? Don't think I'm an amateur who's easy to trick.
We're not done yet. In the real world, there's no God standing by shouting, "Ready, set, go," to synchronize all events. We still need to consider a crucial factor: phase. Imagine someone lets out a fart in the classroom.
Ugh, what a gross analogy.
As the fart smell slowly spreads with the person who farted at their center, people in the classroom will smell it one after another and blurt out, "Ugh, it stinks. Who farted?" See, everyone is saying the same sentence, but the moment it reaches your ears is staggered. That's a time difference, which is a phase difference.
Hey, you're right. What should we do about that?
To enable inner product reveals all to analyze signals of different phases, we must send out two observers for the same frequency. These two observers must be complementary, just like sine and cosine. Because they are orthogonal on the unit circle, their observation phases are exactly 90 degrees apart, allowing them to jointly capture signals of any phase, forming a detection network with no blind spots.
Do we have to use sine and cosine that are 90 degrees apart? Can't we use other angles?
While other angles could also combine to form all phases, they would introduce computational complexity and uncertainty, which is not convenient. Sine and cosine are the most elegant and concise choice. Thus, the third form of inner product reveals all, and the core of the Fourier series, is that AN continues to use the cosine inner product standardization from the previous form, and BN is the sine inner product standardization.
So the Fourier series is just calculating the similarity between a periodic function and a bunch of sine and cosine functions of different frequencies. But the formulas you wrote are still different from the textbook.
Do you think that's the end of it? The wisdom of an engineer is like this: what can be calculated beforehand should never be postponed, and what can be shared should not be calculated repeatedly. Look, the standardization factors of sine and cosine, which are the integrals in the denominator, have fixed values, and one multiple and above is t divided by 2. The cosine frequency zero multiple is t, and one multiple and above is t divided by 2. We can calculate and factor these out in advance. Rearranging the formulas will lead to the final form, the very one that strikes fear in the hearts of students in textbooks. This is the ultimate form of inner product reveals all.
Wow, it's true. The formulas I used to memorize were derived this way. But what are we supposed to do with these calculated A's and B's?
Good question. We calculate them in order to decompose, and decomposition is for the purpose of reconstruction. We can manipulate these components and then synthesize them into entirely new signals. But that's another story.
Damn it, another cliffhanger?
This has been an intuitive explanation from Bala and CC. If you are looking for general academic information, you can find the link to supplementary materials in the video description. We also created an AI teaching assistant group for today's video content. You can discuss any related topics from this video with the assistants. Don't want to miss Bala and CC's explanation videos? Then don't forget to subscribe to the channel.